Most of that stuff you've already seen in my last mailbag card link, and its purpose is to build a temperature controlled water bath. At least that's the long-term goal. Right now I just need a water bath that I can heat somehow and somehow control the temperature, and that was not in the mailbag. That was somewhere in a box, and that is my temperature controller for now. And I need this for etching boards and having the etching solution at a defined temperature of 45 degrees C. Now, I don't have a real plan this time. I'm kind of winging it a little bit. So I've got that heating element, which goes up to, without load, nominal 250 degrees, in reality 240 degrees Celsius. And I have somewhere out of the microwave a temperature switch, which should go here somewhere and limit the whole thing to 180 degrees plus minus 10 degrees. Yeah, just to be on the safe side, because I intend to use thermal glue, and then the whole thing has to go into a case. Yeah, so in the end this will all closed up, and then you don't want to have a 250 degree heat source somewhere here. So in case something goes wrong with the regulation, the temperature switch will kick on. And of course, to have a regulation, I need a, I've shown these things. I modified that one a little bit. I will show you the details later. On the other side, there will go a temperature sensor right here. But I also want a second temperature sensor here at the corner. The idea being I can, in my future controller, see the difference between the temperature of the heating element and the temperature actually of the stainless steel tray, respectively, with a few degrees of the water in the tray. And for example, if that, I mean, you can use it for regulation. Buzzword PID regulator. But also, if that differential gets too big, you know that the whole thing is running dry, because this is thin stainless steel, and the temperature differential between these 2 points will be much bigger if there's no water in it. So, but before I start with all that stuff, there is a slight problem. This is not plain. In fact, there is one corner which is slightly bent or got bent during transport, and this would make it, this corner is also slightly bent, so the corners of that side are bent, which makes it, of course, hard to put it later on in some kinds of a case and have a good seal around here, probably with silicone, because silicone can stand the temperature. So I will first try to get these corners nice and flat. Now, after some bending action, this is no longer it's still a little bit wiggling around, but it's not as bad. I want to pre-bend it so it's reasonably flat, because if I glue that on later and yeah, then this is glued in somewhere or screwed in, I want to avoid getting any tension here on the glued connection. Okay, anyway, I want to put this K-type sensor here at the corner, and I have here still an original one just for comparison. So the original has that heat shrink tubing all around it, which basically isolates the K-type thermocouple, which is only that very, can you see that? Probably not. That very tiny bubble here from the environment. And then you have the heat to travel all the way here through the metal. So first of all, I took the heat shrink tubing away, and then I bent that thing slightly so it will, now do I have somewhere a surface, will be attached this way. Actually, the thermocouple touching my stainless steel tray, and yeah, we'll see how this works out. So I will try to glue that down with thermal glue, and hopefully it works. If it doesn't work, I need to come up with another solution. So what I've done so far is I cleaned all the surfaces with some alcohol, and I have this piece of wood at the back held in place, and I have, with a lot less pressure, keep the cable in place, and a third clamp will press down directly on the washer, and a fourth clamp will, yeah, I already cut it to size, clamp down the extension here and the cable with the thermal element, hopefully evenly down. And then I will cover up the whole thing with a little piece of plastic foil, so I won't glue my clamps to the whole thing. And yeah, this is a little bit fatty. I don't know if that really works as a separator. We will see. Okay, yeah, this is a bit fiddly. I'll do it off camera. So this is how it looks like right now, and now I will let it cure at least 15 minutes. Probably I give it, just to be on the safe side, half an hour, and then we guess have to put some holes in here for the temperature switch and the other PTC sensor. So that was curing 3/4 of an hour, and yeah, let's get the clamps off. It hasn't cured at all. So, and this could also be that I was maybe pressing too hard. So what I shall do is apply more stuff. And remove the excess a wee bit. And then clamp it down again. And we'll see how this will work out, but I probably, yeah, have to leave that there overnight also. And if it's then still not cured, I don't know what to do. Then I really have to, also from that mailbag, to say that the thermal glue is not really working. So it's more than 2 days later, and yeah, it seems to have settled now, and if not, then I need a plan B anyway. But let's say the, what was it, 5 to 50 minutes settle time for that glue is a complete, and putting a little bit of fat on that plastic foil, that worked really good. Yeah, that's sitting in there now. Nice. So the max 50 minutes settle time for that stuff is an absolute fantasy value. I mean, this is obviously silicon based, and silicon needs oxygen from the air or moisture from the air. I'm not quite sure, but something from the air to settle, to harden. And of course, if you put that just on the surface, on the open, it will settle quite fast. But in in a real scenario, like gluing, I mean, this is a thermal adhesive. So, for example, gluing a heatsink to a piece of metal or whatever, the moisture or the oxygen from the air or whatever what's needed to settle that stuff, it has to creep in from the sides, and that's a very slow process. Yeah, but yeah, it's settled. Okay, temperature sensor glued in. What I will do now is first measure if there's still a connection here, and then I think I clean the rest and tape it down the length of it with some Kapton tape. So I opted to glue down the rest of the cable of the sensor with that silicone adhesive first. So that's curing now. So now I have a little bit time to prep the heatsink, which should take on the thermal switch, just to be on the safe side. 180 degrees C that was, and another thermal sensor. So I need 2 holes here. In addition, I need to a little bit countersink. Ooh, yeah, that looks awful. Can you see that? Yeah, that area is all fully bent. So I guess I will countersink that simply to connect main earth to it. And I will also branch off from here with some, yeah, that's some copper I salvaged from an old laser printer, some grounding works. I will somehow branch that off to the stainless steel tray so that both are connected solidly to main other way around. So they are both connected solid to main earth, because having the silicon adhesive here between the heating element and stainless steel tray might actually provide some isolation. And in case something goes wrong with the mains AC, you don't want that. You want everything nicely earthed. So okay, doing some holes now. Yeah, the holes are there. The screws, okay, that was too much, are all nicely countersunk. Yeah, when they're screwed in. No problems there. I also prepared another of the thermocouples, so bend this a little, so if this is screwed down, the actual thermo element, thermocouple, is pressed to the case. Yeah, and there's only one problem left. I think I showed that in the review. This is not exactly flat here. There's a considerable bend. That bend here, that has to go before I do anything else. Okay, now the whole thing is yeah, there's still a little bend here. Oh no, it's acceptable. Yeah, I mean the thermal glue goes in here, so yeah, you can only bend so much before you start making it worse. So now we can clean with a little alcohol and start putting the parts on it. Just a wee drop of, because I have it open, and here, thermal glue. There. For the thermal switch. I mean, this shouldn't be a problem at all, because it will be screwed down. Wonderful. Now for the sensor. Now this might actually be a messy business. Indeed, a messy business. Okay, I guess that can cure now too. So it's yeah, next day, 20 hours later, and it seems to me like, yeah, it's cured. So you don't need 2 days. 20 hours are probably okay. maybe a few hours will be enough. I don't know. Yeah, before we proceed, I want to check out if the thermo elements actually survived the treatment and are still in working condition. For that purpose, I connected the sensor up again to my multimeter and have my standard sensor also in the vicinity, and yeah, it looks good, 30 degrees, 30 degrees. But now I want to show you a little trick. So I'm pulling here the negative end of my built-in PTC, and nothing happens. It still displays a temperature. Now if I just lift that up a little bit, we get an open connection until, and this is no magic, this is just something you have to know about these PTC sensors, until I establish again a ground connection. Yeah, the thing is, many of these sensors, in this case the washer, is electrically connected to your thermocouple. So in that case it's connected, or will be connected, to case ground. This might cause some problems with ground loops in the end, because I have a case ground that obviously will be connected partly to my heating element, and this will have a ground wire. This sensor has a ground wire out, and the other sensor, which we will have a look in a second at, has also its own ground wire out. So yeah, just have to, keep that in the back of your head. So yeah, that sensor also obviously survived. Yeah, plus minus 1 digit. You have to expect that. And the same trick works here. You see, my other sensor is currently touching the metal case, so I should be able to remove the ground. Oh, not a really good ground connection. Ah, okay. So we'll give it another ground. Okay, everything's fine. And yet these are different temperatures. If I take that between my fingers, it will react. Sorry, between my fingers. And the next step, logical step, would be to mount this monstrosity on top of here, also just with adhesive. And I already prepared that a little bit, because I don't trust that plate just glued to that plate with some silicone compound to carry mains earth if required in isolation fault, and this will be filled with water. I want to attach here an earthing strip just in case. So, slight change of plan. I have here now just additional copper contact. Yeah, easier solution. And yeah, I will clean this now with some alcohol and glue it together. And yeah, this will be supported by 2 books. That's interesting. Never read it. And yeah, Stephen Hawking. And yeah, then some wood on top of it, and one or two very heavy transformers. And then it will cure overnight. But yeah, I do that in some corner of the room where I cannot accidentally stumble about it. Just a quick look at the Tower of Hanoi. I will return with that, and it cured overnight to the bench. Now, this looks quite good. And yeah. Can you see that? Yeah, there in the corner there is a little air gap, but yeah, that's where it bent, but yeah, where it counts, everything seems to be hunky-dory. Yeah. Yeah, we will see how this works out. So, yeah, it was bent in the first place. I did my best. Of course, you could always put in a thicker layer of that thermal adhesive, but yeah, then you have where actually the heat is generated higher resistance to my bowl. Yeah, before we continue, I wanted to check something, and that was if I really have now a good connection here with the copper stuff. This will be my main earth. Wrong color, I know. A wee bit high. I will try to put some solder on here. Just a minute. So yeah, just 2 blobs of solder, and soldering stainless steel is almost impossible, but I think yeah, 0.4, 0.3. Yeah, I mean, this is not a milliohm meter, so yeah. 0.2. Okay. That's better. Yeah, I need to clean that up. That looks awful. Looks, yeah, not great, but better. I don't know what that hard stuff is. I didn't get it away with alcohol, but yeah. Anyway, yeah, I don't know if I already mentioned it, but that cable stuff here, and I have some more snippets of it that I probably need, and some sleeve that comes off the fuser unit of an old laser printer. It's not marked, but I tested it with the soldering iron to withstand 250 degrees Celsius, so yeah, I'm fine with that. And yeah, obviously all these connections have to go somewhere in the end. Yeah, we'll see. But before that, I need a case. At least an improvised case. And the only thing I could come up with is this. Yeah. I hope the wife won't miss it. So, yeah. Let's go on with that. Yeah, I know the box is too small, but at least the cable ends will all be inside some metal enclosure. And yeah, this is just improvised, so I can test and play around with it without being in too great of a danger of getting myself shocked, injured, or even killed by mains AC. Great. Can you see the lines? Yeah. So a little bit. You can see the lines. But that's obviously not the line I'm cutting. I have to go from there a little inwards. About 13.5 millimeters. So I say 14 millimeters, or, okay, be generous, 15 millimeters. So I don't have to cut twice. Something here would be nice to guide that thing. Yeah, that should do. Not really. This is relatively awful, but will have to suffice for the moment. Yeah, the second one already went better, and the third one yeah, I guess I have to wing it a little bit. Yeah, and then I have these corners, and yeah, with the wrong radius, of course. Just awful. Anyway, it's Dremel time. Or in my case, Proxon, the better Dremel. Now I also need to cut from that side here. Yeah, basically that shape. And yeah, we will need there about 48. And let's do 49-ish. Yeah, we'll see. Okay, and back to cutting. Yeah, there rises the sun. Question is, does that really fit in here now? And I must say, well, still a little bit of fine work to do. Okay, I guess that's nice enough for now. Yeah, well, I butchered that one, but it's okay, it's only temporary, and now I'll clean up the edges a little bit, and yeah, then we'll go from there. Yeah, I went through quite a few of these cutting discs, but now, and it's not really nice, but yeah, it's nice enough. I mean, this is only a temporary case, so I can experiment a little bit with the stuff. And yeah. So it's too long, I know. Just a wee bit. Yeah, I made sure the temperature sensor here is not really touching. I'll probably tape that down with Kapton tape or something like that. Yeah, but now we have to take care of the innards. And this means I need opening for a power cable and 1 or 2 openings to get my probe cables out. If I do it in exactly the right order, I should be able to squeeze a power cable plus the 2 thermal element cables through that cable bushing here and then squeeze it shut. So yeah, all I need is another hole here in the side. And of course I need 3 clamps for the power, and yeah, these are nice ceramic clamps. I mean, yeah, the bushing not so much, so if that's melting and flowing away, that's too bad. But here, yeah. I forgot to show the drilling, but yeah. So my main cable is coming in here, and yeah, this is all still a wee bit wobbly. It comes all through the cable gland, and yeah, this is pressed down. That is not moving, so that's okay. Yeah, my main cable comes into this ceramic clamp, and yeah, of course, another main earth connection to the case. Just because it's a cookie box doesn't mean it has to be grounded, you know? I mean, doing mains AC stuff, mains earth is your lifeline. And yeah, now I'm going to cable that stuff up, and I have to think about it for a bit, and yeah, get the soldering iron out and clamp 2 quick connects on here, I guess. Yeah. I'll show you the result. So, almost finished. Almost. Yeah, it's a little bit crude, and all my mains AC lines ended up being blue when they go through the clamp. But I managed to, yeah, the ones that are live and neutral have these, I guess it's silicone, because it also can withstand 250 degrees, silicone sleeves, also from that old fuser unit. Yeah, last security check. Just out of interest, the cold input resistance is 1.7K. Oh, that's interesting. And neither from here not from here. That's my body. Do we have any connection? And from main earth, here you need to be sure. Yeah, that's oxide layer. Just make a hole into it and everything's hunky-dory. Yeah, I already tested that and that. That's wonderful. Okay, let's shake out everything that might be still in here and metallic. Put the lid on. And no, I forgot something. I wanted to put some thermal insulation, at least here on that sensor. So it really shows me the temperature of the tray. So that's the only stuff I could find that didn't immediately melt away at 150 degrees. Again, soldering iron test. So yeah, let's put a little bit of it on top of the sensor. So that should improve that the behavior of that sensor considerably. Just a wee bit insulation. And now we can close up that thing. And dispense more Kapton tape around here to help everything together. And also to limit any possible ingress of water. As I said, we are just improvising here. And at some point this will all go into a nice case with a nice microcontroller controlling the temperature or something like that. And here you have it. Wait, we still have to do that inline switch here. Yeah. I'm just not sure where to place it. Sorry. Working a little bit off camera here. So quarter way would be about here. Yeah, I think that's okay. Yeah, and as always, test. We still have ground connection, wonderful. The switch is in the off position, so I should have here nothing. Switch in the on position, and I think we measured 30K. Now we're measuring 1.6K. And now for the great finale. I have here half a liter of water. which doesn't cover the thermometer completely, so I add another half a liter. Just a second. Okay, another half liter should do the trick. Yeah. And I hope you can read the power meter. That should be watts. And I don't know which temperature sensor is which. I forgot it. And now I switch that on and we see what happens. So it's drawing 470, 570, 550 watts. And now it's coming down. 550 watts. That's a lot. And okay, the big one is the one on the heating plate. And you see the heating plate, which, I don't know. I think I already got a card to the mailbag and the review and the link. The heating plate normally without load goes up to 240 degrees C. So this is pretty good. And yeah, let's see what's happening here. You can see in the middle little bubbles forming. That's a good sign. Oop. That means temperature is going up. Yeah. Just watch it rising. Yeah, 40 degrees. I'm still pulling 270 watts. My heating element is at 78 degrees Celsius. And yeah, this temperature here in the corner is a wee bit off. So it's not completely in sync with that temperature reading here. And yeah, honestly, I trust that thermometer just a wee bit more. But yeah, I want to etch at 45 degrees. And yeah, we are almost at 45 degrees. Also, I think the temperature here in the middle is maybe even higher. Yeah, some stirring might help. Stirring always helps. Yeah, but now this would be too hot for etching solution. So I forgot I'm switching off now. And the temperature of the heating element should drop immediately. So yeah, regulation wise, if I ever build a controller for that, there has to get a lot of work into it. From the electrical side, I told you all the ground loops I have now here. I have to take care of that. And of course, the regulation itself, the algorithm, might also be non-trivial, but just, to heat some water up now in a slow, controlled manner. And yeah, it's cold. It's actually, the case itself is quite cold. On all sides, that's good. This is, of course, quite warm. Now we come to an equilibrium, slowly but surely. 50 degrees Celsius, 49 degrees Celsius. And this is in line with the temperature reading here. Yeah, you got a little bit of an offset. It's, yeah, 48.5, something like that. Yeah, there will be more parts to this project, but now I can heat up some water for etching, and that means I can continue with my current main project, which is the UV exposure unit. If I forgot it, card link. I think I already put it somewhere. And yeah, then I really need to continue with the rebuild of my vintage power supply. Yeah, never forget that. I probably ran out of cards a long time ago. If not, another card and another link. The link anyway. Yeah, that's it for today. And as I said, there will be more parts to this, but it will take a while. So, bye.